Good morning, students. In JAM 2021, a question is asked from linearly graded PN junction. Okay, so first of all, we understand what is the difference between a abrupt PN junction and a linearly graded PN junction. So generally, in your textbooks, the PN junction which is given, that is abruptly graded PN junction. So what is PN junction? So this is your P region and there is a N region. Okay, and between these two regions we have depletion region. Okay, so say this is my omega by 2. Okay, this is minus omega by 2 and this is my plus omega by 2. Okay, so N region, in N region we have donor. Okay, so donor will get positively charged, so this is plus, and here we have acceptor ions which accept the charge carriers, so they become negatively charged. Okay, so this is my PN junction. Okay, so if we draw the charge density, okay, charge density, so we see the charge density suddenly varies from when we go from P to N region. Okay, so if you see charge density profile rho, okay, so here we have QND, okay, while here we have minus QNA, where ND is the dopant ion concentration, Na is the acceptor ion concentration. So when we go from P to N region or N to region, charge density, okay, as function of X suddenly varies. Okay, so that's why that junction is called abrupt PN junction. Okay, now if you want to calculate the variation of electric field, okay, along this depletion region, so we know the Poisson equation. So Poisson equation is given by d upon dx upon rho upon epsilon. Okay, in a medium we can solve this Poisson equation, and if rho is known, agar rho pata hai, if rho is known, then we can find E, okay, in this depletion region. So now rho is constant, it is given. Okay, so I can integrate this equation. Okay, so I can integrate this equation from 0 to E, okay, rho x E. So this will give me electric field as rho x E plus constant. Now if I apply boundary conditions, I know at x is equal to plus omega by 2, charge density becomes suddenly 0, so electric field will be 0. So at x is equal to omega by 2 or w by 2, sorry, w by 2, w is the width, so x is equal to w by 2, my electric field will become 0. So this will give me 0. This will give me C equal to minus rho epsilon w by 2. Okay, so if I calculate the E value, so the E value will come out rho epsilon x minus w by 2 for the region 0 to omega by 2. Okay, so this is for 0 x between 0 to w by 2. So this is my electric field value. So if I put x is equal to w by 2, my E will become 0. Okay, so if charge density is 0, the electric field also will be 0. Okay, and if I put x is equal to 0, then it will at x is equal to 0, my E will be minus rho w 2 epsilons. Okay, so it will be maximum. So at x is equal to 0, electric field will be maximum. Okay, so similarly, if I draw this for P region or P side, okay, so I can calculate charge density. So this will give me, so here charge density is given my QND. Okay, so here charge density is QND. Okay, Similarly, if I calculate this for p region side, okay, so this will give me electric field value as minus q n a x plus w by 2. Okay, so if I put x is equal to minus w by 2, okay, so this will give me E is equal to 0. Similarly, if I put x is equal to 0, it will give me q n a w by 2. Okay, so yes, q here also I can put q and d. So this is for reason 0 minus w by 2 to x 0. Okay, so this is my value of electric field. Okay, now I want to draw this one. So if I put this one, this is the value between the region w by 2 to x. Okay, now let me draw the electric field. So if I draw the electric field now, okay, so this electric field, okay, it's 0 here and maximum at x is equal to 0. Okay, and similarly if I go in p side, this will be my electric field profile. Okay, so this is minus w by 2 and this is plus w by 2. Okay, so this is my electric field profile for abrupt pm junction. Okay, but in the questions they have given me now linearly graded pn junction. Okay, so now I want to calculate the electric field profile for linearly graded junction. So how will do? So now in second case, so in second case they have given the question they have given rho is function of x. So rho is function of x. Okay, so this is my w by 2. Okay, and this is my minus w by 2. Okay, and this is n type region and this is my p type region. Now I want to calculate. So say my rho is say q alpha x. Okay, rho is given as rho is proportional to x. So say this is rho is q alpha x. Okay, or you can simply put alpha x. Now I want to calculate the electric field. So again I can apply Poisson equation. Poisson equation say d by dx is equal to rho upon epsilon. Okay, so this will give me d upon rho epsilon and rho value is q alpha x. Okay, dx, if I integrate this equation from 0 to e, okay, so this will give me q alpha x square upon 2 epsilon and a constant. Okay, so I know at w by 2 charge density is 0, so E will be 0. So the electric field will be given by q alpha x square by 2 epsilon plus c1. If I calculate the value of c1, okay, so at x is equal to w by 2, okay, E will be 0. If I put this condition, so this will give me q alpha 2 epsilon, okay, x square minus w by 2 whole square. This is the profile of electric field. Okay, x square minus a square type. Okay, so now if I draw this electric field profile with respect to time, with respect to x, So what I'll get? So if I draw this one, so we can see here when x is equal to w by 2, okay, e is 0, and x is equal to 0, this will be minus, e will be minus q alpha 2e minus q alpha 2e omega by 2 square. Okay, so if I plot this profile of e, okay, so x is equal to minus omega by 2, it is 0, and similarly at omega by 2, okay, also it is 0, and it is maximum on x is equal to 0. Okay, so this will be my profile of electric field. Okay, so this option is B. Okay, so this question is given in 2021 JAM. Question number is 24, MSQ 2 marks. Okay, thank you very much.